Greetings of the day. Myself, Ramya Palaniappan from the Department of Computer Science and Engineering, Madanapalli Institute of Technology. So, in this session, we are going to discuss about the introduction to deep learning. The topics that will be covered in this session are need for artificial intelligence, perceptron and neural networks, types of activation functions, perceptron algorithm, types of loss function, and finally the references and feedback. So coming to the domain artificial intelligence, machine learning and deep learning, these three domains are interconnected and artificial intelligence being the very basic domain from which ML and DL has emerged. Artificial intelligence, also termed as AI, is the technology that enables computers and the machines to simulate human intelligence and problem solving capabilities. As we all know, we being the humans, we have the intelligence to analyze the things, to see the things, and make the decisions based upon our sixth sense. So, likewise, in the case of artificial intelligence, we are going to train the machines in such a way that they are going to look at the things like humans. Similarly, they are going to make some decisions like the humans. So, machine learning, it is a subset of artificial intelligence and computer science that focuses on using the data and the algorithms to enable the AI to imitate the way that humans learn and gradually improve in its accuracy. So from the diagram, we can see that artificial intelligence is the major domain from which machine learning has emerged and from which deep learning has emerged. So how the deep learning differs from machine learning. So machine learning, by the term itself, we can understand that it is about we are going to make the machines to learn like us and understand like us and make decisions like us, the humans. Deep learning is one step ahead of machine learning, in which we are going to train the machines in such a way that it is going to have a kind of structure that is inspired from the human brain to make the decisions by having n number of layers under the convolutional neural networks. Coming to ML versus DL, machine learning works with labeled data set to inform its algorithms how it works in the case of supervisory learning. But labeled data is not mandatory for learning. It's unsupervised learning. So when it comes to machine learning, there are two types available in that. One is supervised learning, in which the data set that is given for the model to get trained will be having labels. Similarly, the next kind is the unsupervised learning, in which the data that is given for the model to get trained will not be having the data, will not be having the labels for it. So the deep learning, it is another kind of machine learning. It can ingest the unstructured data in its raw form. The data can be text or the data can be images, from which the deep learning model can extract the information from it, and it can be automatically determine the set of features which distinguishes different categories of data from one another. So when it comes to machine learning, it involves a lot of human intervention that we have to make the model to understand. We have to train the model in such a way with the labeled data to think like us and to take decisions like us. But when it comes to deep learning, even when you're going to give the data in its raw form, the model is going to understand the features that was hidden in the given data, and it is going to learn by itself such that the human intervention is not that much required there. So machine learning involves more human intervention to learn, whereas deep learning requires very less human intervention at the cost of large amounts of data. So deep learning, when you think about its advantage, actually, it does not involve that much of human intervention. But the disadvantage is that if you want to train a deep learning model, you need enormous amount of data. For example, for the same problem statement you have in your hand, when you're going to train the model using ML algorithms, for example, if you need thousands of data you have in your hand, when you are going to train the deep learning model to solve the same problem, it is not required that only thousands of data will be useful. You need 10,000s, even 20,000s or 30,000s of the data observations to make the model to understand. So ML has its own benefits. Similarly, DL has its own benefits. When it comes to DL, human intervention is less, but at the cost of having large amount of data, or you can say enormous amount of data. So deep learning is not different from machine learning. Deep learning can be thought as a scalable machine learning, which means that you're going to increase the level of understanding by the machines by using different kinds of deep learning frameworks. Labeled data and unlabeled data. As I told you before, when you're going to train the machine learning model or a deep learning model to perform the business decisions, to make the predictions, definitely data given for the model makes a bigger contribution towards making the model to get trained. So the data can be either a labeled data or it can be an unlabeled data. So here is the picture that shows how the labeled data looks like and how the unlabeled data looks like. On the left hand side, you can see the samples of images of dogs. For an example, we are going to train a ML model to classify between the images of dog and the cat, a conventional example that can be taken. So you can see that in the case of the first column that was present there, we have images, two sample images of dog and two sample images of cat. And it was clearly mentioned that it is a dog and it is a cat. But on the right hand side, you can see unlabeled data. In there you have first two images that belongs to dog and the second two images that belongs to cat. But it is not labeled, which means that they are not given a name there. So this labeled data can be used for machine learning models. Yes, whereas the unlabeled data, it can be used for deep learning models. So it is not required that I have to label the data individually for each and every data observation. Instead, the model is going to understand the features that was present in the images and it is going to label itself, this is the images of the cat or these are the features of the cat. Similarly, these are the images of the dog and these are the features of the dog. Likewise, it is going to understand the features that was present in the data set that you're giving. So labeled data, it works with the machine learning models, whereas unlabeled data, it works with the deep learning models. Real-time problems where ML fails. Actually, machine learning model can be used for, machine learning domain can be used for solving many of the real-time problems. But there are certain domains, or you can say there are certain situations or scenarios where the machine learning algorithms fails. So some of them are image detection, image recognition, natural language processing, chatbots, and autonomous cars. So these applications are self-explanatory and they are the hotcakes now. So image detection is about, I want to detect the images. I want to find whether it is the image of a dog or a cat, it is the image of a brain, it's the image of a kidney, likewise. Image recognition. So given the images of n number of human beings, for example, it's about identifying the face of n number of people working in an organization. It is about recognizing the face as it belongs to which person. That is what is image recognition. Natural language processing. So how we are going to understand the languages and we are going to answer likewise. The machines are going to understand the languages and is going to process. And the next one is chatbot. Yes, of course, we know we have verbal chatbots and we also have text chatbots, which is nothing but based upon our queries, it is going to give us the suggestions of the answers. And the last one is autonomous cars. It involves a lot of applications that is running behind it to make it happen, which means the cars are going to be driven and it is going to work without having the humans to give the commands for it. So these are the sophisticated applications where machine learning algorithms fails and we need to reside upon deep learning as the next level to work on these applications. Coming to deep learning model, the very important component that makes up a deep learning framework is perceptron, or you can say that it is an artificial neuron. So from the picture, we can see that there are three different circles there. One is X and second one is Y and third one is Z. You can think that they are the neurons. Okay, so these neurons will carry some information and that is being processed together to give a certain output. So the perceptron can also be termed as artificial neuron. It's a linear model used for classification. So there are many kinds of models, linear model, non-linear model. So here linear model is used for classification. As I told you as a conventional example to classify the images of dog and cat. You can take that one also to understand here. So it is about for classification, we are using a linear model, which means that it is going to take a number of inputs to it. It is going to process it and give some output out of it. And it accepts the multiple inputs. So it is going to accept n number of inputs. It might be too many. So sum them along with the weights for all and finally applies the activation function and gives the output. So from the picture you can see X, Y and Z are three inputs and they are given some weightage. You can see there W naught is equal to 1, which means the neuron X is given a weightage of 1. And W1 is equal to 0, which means that neuron Y is given a weightage 0. And the third neuron is it is given a weightage W2 is equal to 0. So each input is given a weightage, which is nothing but the importance. Okay, so the input is multiplied with their weights, and once they are multiplied, they are summed up together using a summation factor, and then an activation function is applied. You can see in that picture that there is a sigmoid kind of symbol used there. It represents the activation function that was utilized there, and from that you will be getting the output. So when you mathematically represent the operation that is being performed for this process, you can see there S represents the output. S is equal to X into W0 plus Y into W1 plus Z into W2. And you're going to apply the activation, or you can see the transformation function that gives the output, which is nothing but function of S. Okay, F is the activation function that is applied to the summation value that I have got in the previous step, F of S. This is how the artificial neuron works. So where did we get that inspiration of having an artificial neuron? Is that it is not from anything else, it is from our human brain. So neural networks to mimic the human brain. So the human brain captures and processes millions of information, which is transmitted as electric signals through our brain nerves. So when you see a picture, actually through our sense organs, we are going to sense something, and that is transmitted via our our electric signals. The information is transmitted via the nerves. It reaches our brain, and in our brain, it is going to be transmitted again as electric signals, and we are going to identify what kind of image it is. This is how it is working naturally for us. Similarly, from this kind of inspiration, inspired from the brain nerve architecture, it laid the foundation for artificial neurons, thereby forming a neural network. So in case of deep learning, we are going to develop a neural network, and that is inspired from the working nature of human brain nerves. How the brain nerves are getting electrified, or they are getting switched on by transmitting the electrical signals. Likewise, here also, the artificial neurons are going to get sparked, or it's going to get electrified on by the transmission of the data. So the neural networks, or the artificial neural networks, are comprised of. So what are all the components present in the neural network is that they will have node layers containing an input layer, one or more hidden layers, and an output layer. So the important components of deep learning model are, they will definitely have an input layer to get the input from whatever it is, data or from the user. And it will have the processing layers, and they can be termed as one or more hidden layers. And last one is the output layer, from which we can expect the output. And you can see in the image how it is highlighted. You have some dots, numerous amount of dots that represents one neuron. So likewise, in deep learning model also, we have lots amount of artificial neurons, or you can say perceptrons, that is going to carry the information, and that is being transmitted from one neuron to another. And that's why from these transmission, we are getting the output. Coming to the artificial neural network structure with its layers, as I told you already, each neuron is going to have its own inputs, its own activation function applied, and then the output is there. So each node or the artificial neuron connects to one another and has an associated weight and threshold. So this is a different term I'm telling now. Threshold. Each node will have its own threshold value that is being connected there, that is being fixed there. If the output of any individual node is above the specified threshold value, the node is activated, sending the data to the next layer of the network. Otherwise, no data is passed along to the next layer of the network by that node. So you can see in the image, you have input features, and you can have n number of hidden layers. So it is not fixed that 2 layers can be there, 3 layers can be there, n number of hidden layers can be there. And that's why when you're having more number of hidden layers, it is referred to as a deep learning model. How deep it is represented by how many number of hidden layers it is having. And last is your output, that is the prediction. So each neuron, they will have a threshold value. Threshold value, which means that a maximum value that was fixed for that. So if the output from that particular neuron crosses the threshold value, then that particular data from that neuron is transmitted to the next neuron in the next layer. Okay, so because of this, the data is being transmitted. So the deep in the deep learning is just referring to the number of layers in the neural network. Activation functions, as I told you, perceptron will have the weights. Similarly, perceptrons will have the threshold. Similarly, the summing up of the inputs along with their weights will be passed on to the activation function, and this activation function is going to decide what kind of output will be transmitted to the next level or the next neuron present in the layer. Okay, so there are variety of activation functions are there, and the usage of activation function depends upon what kind of problem you have in your hand for solving. So it uses a threshold to produce the output. It uses a threshold value to produce the output. You can see in the diagram. The sigmoid symbol, it represents the activation function. The n number of activation functions used are, first one is unit or a binary activation function. Second one is sigmoid or logistic function. Third one is tan h function. Fourth one is ReLU function. A rectifier linear unit. It stands for rectifier linear unit function. And the last one is softmax activation function. So these are the various kinds of activation functions that will be used when you're going to design a deep learning model for the task that you have in your hand. Coming to the first type, unary step or the binary function. So you can see in that picture actually, there are only two outputs here. One is that it might be either 1 or it might be either 0. That's why it is called as unary step, either 1 or 0. So it can be represented as a mathematical formula. F of x is equal to 1 if x is greater than or equal to theta, and 0 if x is less than theta, where theta is a threshold value. We can fix a threshold value, and when the value of the f of x crosses the threshold value, then the output of that particular neuron, output from that particular neuron is set to 1, or otherwise it is set to 0. Okay, if the input is greater than the threshold, the output will be 1, else it will be 0. You can see that when you are going to set the threshold value, for example, to be 5, you can see the first input I am giving there 7. So 7 is greater than 5, and hence the f of x will be 1. And the second input what I am giving is 2. Here 2 is less than 5, which is the threshold value that I have fixed, and hence the output f of x is equal to 0. So threshold varies. We can fix our own threshold value, and when the input is crossing is greater than the threshold value, the output of the function will be 1, or otherwise it will be 0. Second one is sigmoid or the logistic function. So when to use the sigmoid function? So when to use a sigmoid function is a big question, because as I told you, it depends upon what kind of problem and what kind of output you are expecting from the problem you have in your hand. So when we want to map the input value to a value in the range of 0 to 1, okay, I have an input in my hand and I want to map it to a value within the band of 0 to 1, and I will be using sigmoid function. So on the right hand side, you can see the picture in which the possible value from this particular activation function is that it falls between 0 and 1, and it is calculated using the formula function, sigmoid function of z is equal to 1 by 1 plus e raised to the power of minus z, and the value of e is 2.718. So this mathematical computation is applied to the input x, and you will be getting the value definitely between the band range of 0 to 1. From the table you can see when the input x is equal to 1, f of x is 0.73, which means the formula that was used there is 1 by 1 plus e power minus 1. You will get that answer. Similarly, when I give x is equal to 10, I am getting the value f of x is equal to 0.99. So in the case of sigmoid or the logistic function, the next one, the map the input value to a value in the range of -1 to +1. Okay, so here we are going to map the values between whatever input you are having, you are going to map them between -1 to +1. Before we had 0 to 1, and now we have -1 to +1. So here it is going to deal with the negative numbers. So if your inputs is going to have negative numbers, obviously you are supposed to use the sigmoid, or you can say that a logistic function. And from the picture on the right hand side, you can see how that logistic function is applied. Tan h of x is equal to 2 divided by 1 plus e to the power of minus 2x minus 1. So when you apply the tan h logistic function, or you can say that it is a activation function, this formula is calculated for that particular input, and you're getting the answer. For example, when x is equal to -4, so this tan h formula will be computed there to get the output f of x is equal to -1. Similarly, when x is equal to 2, you will be getting f of x is equal to 0.7. So this is the next kind of activation function. Next comes the very widely used activation function, rectified linear unit, ReLU activation function. So if the input value is less than 0, the output will be 0. Or otherwise, if the input is greater than 0, the output will be the input value. So here actually the 0 is used as a decision factor. If the input value is less than 0 means there will not be any output. It will be made to 0. Whereas if the input is greater than 0 means whatever is the value of the input is taken as the output from that particular neuron, or you can say that the activation function. So you can see the formula how it is mathematically represented. F of x is equal to 0 when x is equal to 0. On the right hand side from the picture itself you can understand when it falls on the left hand side negative values, it will be always 0. And when the value of x is greater than 0, a positive value, then what is the value of the input will be taken as the value of the output activation function, that is x when x is greater than 0. And you can see from the table to understand, when I give the sample input -2, so -2 is less than 0, so the output will be 0. Similarly, when I give the value x is equal to 2, it is greater than 0, and hence the value will be taken as, the output of the activation function will be taken as 2. So this is how the ReLU activation function works, and it is the most widely used activation function when you are going to build a deep learning model. Next one is softmax activation function. This is another important activation function that was commonly used when you are going to work with classification problems. It is used in classification problems when we have multiple classes. For example, consider I am giving the MRI images of the patients, and I want to identify that whether the MRI sample patient is having either a brain tumor, or he is having a Parkinson's disease, or he's having a multiple sclerosis disease, or what kind of. So when I have multiple classes to be decided, that is the particular MRI sample belongs to a specific n number of diseases. It's an example I'm telling. For that kind of multi-class classification problem, I will be using softmax activation function. Similarly, when I not going into the healthcare, when I say generally, I'm giving the images and I want to find whether it is the image of a dog or a cat or a horse or a rat. So for example, here it is 4 classes, right? So when I want to have a multi-class classification problem to be solved, then I can go for using softmax activation function. So how it is going to be calculated? It calculates the probability, or you can say the confidence score of each class, and then makes the classification to the class that has highest probability, or you can say the confidence score. You can see there on the right hand side from the picture, the output layer contains certain outputs from different neurons: 1.3, 5.1, 2.2, 0.7 and 1.1. And here we are going to apply the softmax activation function individually for all the values that is emerging from the different neurons from the previous layer. Okay. And now what happens is that the softmax activation function has its own formula, e power zi divided by summation from j is equal to 1 to k e power zj. It is going to apply that formula, and the output will be the probability. Okay. So, or you can say it as a confidence score. And how many values you are getting? You see, you are having 5 values there, which represents that it is a 5-class classification problem. 5-class classification problem, which means, example, having an image, I'm identifying whether it belongs to class 1 or class 2 or class 3 or class 4 or class 5. And from there you can see, out of the probability values I'm getting, the second class is having the highest value, 0.90. Okay. So here the decision is made that the image belongs to the class 2. Okay. So based upon the highest probability or the highest confidence score, we can decide that the particular image sample belongs to a particular class. This is how the softmax activation function works. Both ReLU activation function and the softmax activation function are the most commonly used activation functions for many of the real-time problems we have. So perceptron for the real-time problems. So it is used for the binary classification problem where inputs are linearly separable. You can see from the picture which one is linearly separable. You can see set 1. It has the data points. It belongs to 2 different kinds of classes. Blue color represents one kind of class, and the red color represents another kind of class. Can we separate them by drawing a line in between them? No, it is scattered. It is scattered. We cannot do that one. See the set 2. Again, you have blue color data points representing one class, red color data points representing another class. Even if I'm trying to draw a hyperplane or a line in between them, Even now, some of the data points are misclassified as either blue as red and red as blue. Again, it is not possible. Whereas you see the third set is equal to 3, third one, here you have the data points, and when you draw a hyperplane in between them, actually you're clearly separating the class 1 data points from the class 2 data points. So the third set of points from the picture, we can say that they are linearly separable. So this is actually the problem statement, finding the hyperplane that properly classifies the data points. So that is the work of the perceptron when it comes to classification problem. So perceptron algorithm, how it is working? As I told you, the perceptron is going to take the inputs, going to apply some weightage for the inputs, and then see whether it crosses the threshold. And when it crosses the threshold, that particular output is crossed to the activation function, passed to the activation function, and then output will be taken. But how the algorithm or the perceptron is going to train itself such that the output from that particular model is going to be good? Because in one training step itself, the model will not give the good results. You cannot expect a good results of 80% or 90% accuracy. You need to train the model with an enormous amount of data. As I told you already, deep learning requires enormous amount of data. The model has to be trained repeatedly such that the performance of the model can be reasonably better. Okay, so the step that is involved for training the perceptron, or you can say artificial neurons, is that step one, assign weights to the inputs. Yes, for the every input, I'm going to assign the weightage or the weights. Second step is provide inputs to the network and calculate the output. So I'm going to provide input for the network or say the perceptron, and I will calculate the output from it. Calculate the error. This is the important step. I will be calculating the error. So how I will be calculating error is that it is the difference between the predicted output. So what is the output got from my neural network, and it is the difference between the actual output. What is actually the output that is required? That is the first one. And what is the output that is given by my deep learning model? That is my second output. So when I want to find the difference between these two, that is considered to be the error. If the difference is more, then I can say that my model is not performing good. I need to train my model more. Now what I will do is that adjust the weights of input. First step is that we have assigned weights now. Now what we are going to do is that we are going to adjust the weights of the inputs, and then we go for providing the inputs to the network and then calculate the output. So step 2 and step 3, which is nothing but providing inputs and calculating the output, and third step is calculating the error. So these two steps are repeated until I get the loss, until I get the error to be minimum. So how I am going to repeat this step is that I will adjust the weights of the neurons in such a way that my error is minimized. Okay. So weights are used to handle the vanishing gradient problem and the exploding gradient problem. So the weights assigned for the neurons plays a vital role when I go for training my model. Vanishing and exploding gradient problem. So we need to know what is the vanishing gradient problem and what is the exploding gradient problem. So when it comes to training the model to make the predictions better with good accuracy, we will be adjusting the weights of the perceptron, and we will be propagating the weights in the reverse direction. That is called as back propagation. Okay. So if the values of the input is very high, the output of the activation function increases exponentially during the back propagation. Back propagation, what is the back propagation is that from the input layer to the output layer, the information is being transmitted, right? That is called as forward propagation. And when you're calculating the output, I'm finding more error, or you can say that the loss is more for my model. In that situation, I will be reducing the weightage for my neurons, and that information will be transmitted from the output layer towards the input layer in the reverse direction, from the right to the left. So that is referred to as back propagation, propagating backside, propagating in the reverse direction. Okay, so when the values of input is very high, the output of the activation function increases exponentially, and it is called as exploding gradient problem. It keeps on increasing more. Okay, whereas the second type, if the values of the input is very low, the output of the activation function decreases exponentially during the back propagation, and it is called as vanishing gradient problem. The second kind, vanishing gradient problem, is actually a very, very tough problem that need to be handled. CNN has vanishing gradient problem, and that is solved by RNN. particularly in LSTM, longest to short-term memory network. So in that, the vanishing gradient problem was solved to an extent. So from the picture on the right-hand side, you can see how it is being done. The first one, you can see the information that is being transmitted from the left-hand side to the right-hand side. And in the second picture, you can see while that information from the output layer is being transmitted from the output layer back to the input layer, the information gets reduced. You can see in the intensity of the picture. Okay, the intensity of the picture reduces when it reaches the input layer on the left hand side, which means that the data is not that much effectively received when it reaches the input layer. This is called as vanishing gradient problem. It gets vanished. It gets vanished from the output layer towards the input layer. So both will make the network slow in getting trained. When the information is not properly transmitted, then the model will not get trained. Similarly, the information that is transmitted is more to get learned, more for the model to get learned, then obviously, then also the model will not be able to get trained effectively. So both are actually the problems or the issues that may arise and that need to be handled when we go for training our deep learning models. Next one is how we can calculate the performance of a model. I'm building a model that can make a classification about whether it belongs to class A kind of image or class B kind of image or class C kind of image. Yes, I'm building a model and I'm saying that I have built a deep learning model that is going to perform this kind of task. How can I say that my model is performing better? How can I measure its performance? It's very simple. I can go for using a metric called as a loss function. So the loss function measures the deviation from the predicted output and the actual output. So what is the actual output that should be there and what is the prediction done by my model? So that should be less deviation between these two. If there is more deviation, then you can say that the loss is more. Okay. So the more the error, or you can say more the loss function, less is the model's performance. Both are actually inversely proportional. Less the error, or you can say less the loss function, more is the model's performance. Am I right? Yes. On measuring the loss function, we can adjust the weights to improve the model's performance and minimize the error. So when I want to improve the performance, I have to adjust the weights and measure whether the loss is less, whether the error is less. When I keep on reducing the loss or I keep on reducing the error, the performance of the model will increase. Okay. And you can see there error is equal to LR y exponent, or you can say that y dash minus y into x. LR represents the learning rate. That is the initial value that was given for the model to get trained, learning rate, and it was gradually increased. And there are many methods for increasing the learning rate over the epochs. Okay, that we will see in the further sessions. And then y dash, it represents the predicted output by my deep learning model. Y, it represents the actual output that is expected from the model, and x is the input. So how we can measure the error is nothing but y dash minus y multiplied by x, and it is again multiplied by the learning factor, or you can say learning rate, LR. So less the error, more is the performance. More the error, less is the performance. Inversely related or proportional. What are the types of loss functions? There are many types of activation functions we have discussed, right? Based upon the problem statements, we will be using different kinds of activation functions. Similar to that, there are many types of loss functions. So Keras and TensorFlow. So it's actually, they are the packages, or you can say the IDEs, or you can say APIs that was available in Google Colab environment, in Jupyter Notebook environment, in Anaconda and Spider environment, that has a lot of built-in loss functions for different objectives. Objectives in the sense here represents different purposes, different problem statements. The very commonly used loss function is mean squared error. It's used for the regression task where the value is a measure of square differences between actual output and predicted output. What is the actual output? What is the predicted output? I'm going to find the difference and then I'm going to square that one. That will be the mean squared error. It is used for the regression task. Regression task in the sense I want to predict a continuous value. What will be the price of the stock, or you can say the price of a particular company's share after 20 years? What is the cost of my plot after 50 years? Likewise, if I want to predict a continuous variable over a period of time, that is a regression task. Whereas what is a classification task? I'm going to identify whether that person will buy a car or not. I'm going to predict whether a person is having a disease or not. I'm going to find whether the image belongs to dog or cat. So this is a classification problem. So mean squared error is used for regression kind of task. Second kind of loss function, binary cross entropy. From the name itself, it is very clear it is used for classification problem, that too a binary classification problem, this or that. Okay. So third kind of loss function is categorical cross entropy. Again, from the name itself, we can understand that it is used for classification problem, but here the difference is that it is not restricted to two classes. It is restricted, or it can be used for n number of classes. Yes, I told on seeing one MRI sample, I'm going to decide whether it belongs to a patient that is having brain tumor, or the patient who is having Parkinson's disease, or the patient who is having multiple sclerosis. It is a multi-class classification problem. If you are going to build a deep learning model to make that classification, then obviously the loss function that is used for measuring the performance of my model is categorical cross entropy. Okay, so these are the different types of loss functions. So these are the different references, blocks, or you can say the links that I have referred to prepare for the session. So from the session, I hope that you have understood about what is the importance of AI, artificial intelligence, and what are the small drawbacks of going for machine learning, and what is the need to go for deep learning. And when it comes to deep learning, from where we have got the inspiration of developing a perceptron, or you can say an artificial neuron, and what are the different activation functions used in building an artificial neuron. And then we discussed about the different types of loss functions used for measuring the performance of the model. So if you have any suggestions, any feedback or queries, feel free to fill up this form so that we can take up the session in a better way next time. Thank you.